Hi everyone, my name is Josh Go and I am joined by my brother Sam Go. In this module, we will be going over 40 sample questions that we picked from previous Algebra II Regents, and the types of questions that we chose are according to the breakdown provided by the Regents board. The breakdown is as follows. For number and quantity, that makes up 10% of the 40 questions, which equates to 4 total questions. For algebra, that's 40% with 16 questions. For functions, that's 35% with 14 questions, and for statistics and probability, that's 15% with 6 questions. Without further ado, let's begin. Alright, so expressed in simplest a plus bi form, 7 minus 3i plus x minus 2i squared minus 4i plus 2x squared is. So it seems like, looking at the answers, we have to first expand this out, then simplify to get into this a plus bi form. So let's take a closer look at this portion of the expression. It's x minus 2i squared. We know that that just means x minus 2i times x minus 2i. We can FOIL this out. I'm going to skip a step here. It's x squared minus 4ix plus 4i squared. Now, we can note that we can simplify this further because this is an I squared. We know that I squared, if we do I equals I squared equals negative 1. I cubed is equal to negative I, and I to the fourth, or I to the 0, is 1. So we can replace this I squared with this negative 1 term, which means this term is x squared minus 4ix minus 4. And now we can throw in the other terms, plus 7 minus 3i minus 4i plus 2x squared. All right. So we can distribute these signs in, right? This one you really have to pay attention to because it's a negative. So let's write this all out before we combine them. Minus 4i, and distribute this in, minus 2x squared. So we can combine these x squared terms and get negative x squared. Ix is a term by itself. You have a minus 4 here. But we have a plus 7 here, so that's a plus 3. We have a minus 3i and a minus 4i, and that's a minus 7i. And that should be it. And then now let's just reorganize this so that we can, group the i's together and group the i's together on one side, so that we have that a plus bi. So it looks like we can group this ix and this I together. We have negative x squared plus 3 on this side. We can do negative 4ix minus 7i. Now in this case, we can just group these together. It looks like the answers look like that right up there. And then for this side, we can simply distribute out the I. This is negative x squared plus 3. And we have a minus I multiplied by a 4x plus 7, right? Because when you take out the negative I, it becomes a positive. Therefore, the answer looks like it's going to be 1. Alright, so given tangent theta equals 7 over 24 and terminates in quadrant 3, determine the value of cosine theta. So I see 2 ways to go about doing this. The first is to use the inverse tangent, or arctangent, to find the theta value. So that's the inverse tangent function of 7 over 24 equals theta. Now you can plug this straight into your calculator and make sure your calculator is set to radians. And theta equals 0.2837 9 And we can simply just plug this theta value into cosine and get cosine of this number equals 0.96. But hold on, we're not done yet. We have this ASTC. You can use the mnemonic all students take calculus. So just remember that in this quadrant, quadrant 1, all trigonometric functions are positive. In quadrant 2, it's only sine and cosecant. In quadrant 3, it's only tangent and cotangent. And finally, in quadrant 4, it's cosine and secant that are positive. So here we said that in quadrant 3, let me circle it. In quadrant 3, only tangent and cotangent are positive. So we know that the value that we get here has to be negative. So we have to remember to put a negative sign before the 0.96. So another way we can go about doing this is actually drawing this out. We know that this is in quadrant 3, so it's here. It looks like that, right? Again, this is not to scale. And theta would be that. We know that tangent, SOHCAHTOA, right? SOHCAHTOA. We know that tangent equals opposite over adjacent. So opposite is 7 and adjacent is 24 from what the question told us. So now we're looking for cosine. Cosine. We know that's adjacent over hypotenuse. So we still have to find the hypotenuse to do this. We already have adjacent, which is 24. So to do this, we can simply do a Pythagorean theorem. We know that h squared equals 7 squared plus 24 squared. And just calculating this out, we can take square root of both sides and get this is a 625, by the way. If you square root of 625, you get 25. And therefore h is 25. We can simply plug this hypotenuse into the cosine, and we can plug the 24 into adjacent. And we know that cosine theta equals 24 over 25. But now we also have to do what we did earlier with this ASTC. We know that cosine in that quadrant has to be negative. So it's cosine theta equals negative 24 over 25, which is 0.96. These two values are equal. So if cosine theta equals negative 3/4 and theta is in quadrant 3, then sine theta is equivalent to. So we can do it in the same two ways as we did the previous question. I'm going to elect to do it the math way, where I just draw it out myself. So we know this is in quadrant 3, so the triangle is going to be here. This is our theta. We know cosine is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 4. And it's asking us for sine, which is opposite over hypotenuse. So we're still looking for this. So you can simply do Pythagorean theorem again. 4 squared, which is the hypotenuse, equals 3 squared plus x squared. To solve for x, we can do 4 squared minus 3 squared equals x squared, and taking the square root of both sides. We can get, this is 4 squared is 16, 16 minus 9 is 7, so radical 7 equals x. So that's our opposite value. We can simply plug it into here. So we know that sine would be equal to radical 7 over hypotenuse, which is 4. But then again, we have that ASTC to look at again. Remember to keep doing that. ASTC. All students take calculus as a mnemonic. We know that we're in quadrant 3, this quadrant again. So we know that sine is also negative. So there has to be a negative right in front. making our answer choice 1. When a ball bounces, the heights of consecutive bounces form a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. The question asks, to the nearest centimeter, what is the height of the fifth bounce? So this is a geometric sequence, which is in the form of a initial value, multiplied by a common ratio raised to the n minus 1 power, with n being the number, the nth term in the sequence. So we know that a should be like our 121 centimeters at our first bounce, right? But we don't know what r is. So let me quickly just visualize this out for you guys. Bounce. They gave us the values for the first and third bounces. So let's find the relationship between those. 1, 2, 3. We have 121 at the first bounce, and we have 64 at the third bounce. We know that through each bounce we multiply by that common ratio, right? So from the first to the second bounce, we multiply 121 by r. Then again, we do that same exact thing. We multiply it by r again to get to 64. So this creates the relationship that 121 times r squared equals 64, which is our third bounce. Now we can verify this with our original, the original geometric formula up here. That when you plug n equals 3 up here, you get the same exact thing. When n equals 3, you also get 121 times r to the n minus 1, which is 2, equals this third term, which we know is 64. So we can simply solve this out to find r. Divide both sides by 121. And we can take a square root of both sides. That's 8/11 equals our common ratio. Now we can plug this common ratio into our original formula. Let's write that out so that we can see it. Now that we have r, we can plug that in as well. We have 8/11 as our common ratio. And now we're trying to find the fifth bounce. So the fifth term of the sequence, n equals 5. 5 minus 1 up here. So let's do that. Let's raise it to the fourth power and multiply that by 121. And that gives us a value of 33.85. Now it's telling us to round to the nearest centimeter, and our answer is 34. So now we're moving on to the algebra portion of the sample questions. Emmeline is working on one side of a polynomial identity proof used to form Pythagorean triples. Her work is shown below. What statement is true regarding the work? Now, the answer choices have like, oh, there's a mistake in a certain step, so let's go through her work and see if she went wrong anywhere. So in step 1, it looks like she multiplied out this 5x squared term. Let's do that for ourselves. 5x times 5x does indeed equal 25x squared. And she brought this entire term down as is. So step 1 is perfectly fine. So in the second step, it looks like she brought this 25x squared term down as is, and she multiplied out this second term. So let's do it. Let's FOIL it out for ourselves. So we have 5x squared minus 5 times 5x squared minus 5. Let's FOIL it out. We get 25x to the fourth minus 25x squared minus 25x squared plus 25. And these two middle terms, we can combine them to negative 50x squared. So it looks like she went wrong in her step 2. She didn't FOIL it out properly. So we know that she went wrong in step 2. So let's look at step 2 to step 3. It looks like she combines these two terms properly, and she brings the 25 down as is. So step 3 looks fine. Step 4, on the other hand, is wrong. She tried to combine these terms, but they're not like terms. You can't combine them like that. So step 4 is wrong. Therefore, our answer is that there's a mistake in step 2 and step 4, and it looks like answer choice 3 says that exactly. This question asks, a number minus 20 times its reciprocal equals 8. The number is. So let's model this expression out. A number, let's have x, minus 20 times its reciprocal, so 20 times its reciprocal of x is 1 over x, equals 8. Now we can simplify this out. X minus 20 over x equals 8. We want to get that x out from that denominator, so let's just multiply both sides by x. Getting x squared minus 20 equals 8x. And we can bring this 8x back to this side by subtracting both sides by 8x. X squared minus 8x minus 20 equals 0. And this becomes x. It looks like 10 and 2, right? So x minus 10 and x plus 2. So our solutions are going to be x equals 10 and x equals negative 2. Answer choice 1. So given y is greater than 0, the expression square root of 3x squared y times the cube root of 27x cubed y squared is equivalent to. So we know that rooting something is just raising that term to a power of 1 over something, right? So let's simplify this out that way. 3x squared y is raised to the power of 1/2, right? This is the square root multiplied by the cube root, so that we know that's it's going to be raised to the 1/3 power. This is 27x cubed y squared. We know that's raised to the 1/3 power, cube root. So we know that if we raise an exponent, we can, well, let's first, I'm going to quickly write 1 here so that we know what we're doing. So we know that if we raise an exponent to an exponent, that's the same thing as multiplying those two numbers. So let's quickly do this first term, 3 to the 1/2, x to the 2 times 1/2, which is 1, and then y to the 1/2, which is y to the 1/2. And then we can do the same exact thing for the second term. 27 to the cube root of 27 is 3. 3 times 3 times 3 is 27, so that's 3. We have x to the 3 times 1/3, which is 1. And then we have y to the 2 times 1/3, which is just 2/3. Now we can try to combine the terms we have in here. So we know that when we're multiplying them together, rather than doing the exponents, that we add them, right? So this first term, the 3 to the 1/2 and the 3 become 3 to the 3/2. Because 1/2 plus 1, that's a full 1, or 2 over 2, is 3/2. Same thing, x to the 1 plus x to the 1 is x squared. And then we also have y to the 1/2 plus 2/3 is 1/2 plus 2/3. We can try to simplify that out. We know that the common multiple is 6, right? So 1/2 is 3/6, and then we know that 2/3 is 4/6, which becomes 7/6. So which answer is 3 to the 3/2 x squared y to the 7/6? It looks like this should be answer choice 4. All right, now Erin and Krista were working on cubing binomials for math homework. Erin believed they could save time with a shortcut. She wrote down the rule below for Krista to follow. Does Erin's shortcut always work? Justify your result algebraically. All right. So let's quickly work this out ourselves before we make any conclusions. We know that a plus b cubed is just a plus b times a plus b times a plus b. Let's work on the first two first. Let's FOIL that out. A squared plus 2ab plus b squared. And we also have that last term, a plus b. So now we have to multiply this here, multiply this here, multiply this here, and same thing with b. Multiply there, and multiply there. Let's work on a first. A times a squared is a cubed plus 2a squared b plus ab squared. And let's multiply the b's in. That's ba squared plus 2ab squared plus b cubed. And now we can simply combine like terms to see if this reflects what Aaron shortcut. So it looks like we have an a squared b here, we have an a squared b here as well. Let's write a cubed first, plus we now have 3 a squared b's, plus now we have a b squared here and an a b squared here, which adds to 3, plus b cubed. So this looks like we can't simplify that any further. So this doesn't reflect the shortcut that Aaron gave, right? And that's really because it doesn't have these two middle terms, the 3a squared b plus 3ab squared. So the answer is no. All right, moving on. So question 9 asks, if f of x equals x squared plus 9 and g of x equals x plus 3, which operation would not result in a polynomial expression? All right, so let's work this out. For answer choice 1, you have f of x plus g of x, which would give us x squared plus x plus 12. And that looks like a polynomial expression. That's fine. So that can't be our answer. And subtracting it would yield a similar result. X squared, 9 minus 3 is 6. And then there's no middle term, so minus x here, which would also be a polynomial, so that's not it. When we multiply it, we get x squared plus 9. It doesn't look like it would violate, right? Just FOIL that out, and it would give us a cubic term, right? But finally, in this last answer choice, you have f of x divided by g of x. Now that offers some very weird results, because you have x squared plus 9 over x plus 3. Now, polynomials can't have their variable in the denominator. So that would be our answer. And this doesn't, just to add, this doesn't cancel out, so this variable always stays down here. However, if the case were x squared minus 9, that would be a difference of 2 squares, and you can actually cancel out the x plus 3 term. But in this case, you can't. So this variable stays down here, and we know that in polynomials, we can't have that variable down there, so this is our answer. Where I is the imaginary unit, the expression x plus 3i squared minus 2x minus 3i squared is equivalent to. All right, let's expand this out, and then we can simplify at the end. The first term is the same as x plus 3i times x plus 3i. Let's FOIL that out. That becomes x squared plus 3ix plus 3ix plus 9i squared. Now we have the second term as well. 2x minus 3i times 2x minus 3i. We can do the same thing. We can FOIL it out. I'm going to bring this minus down from up here. And we get 4x squared. This is minus 3i times 2x which is negative 6ix, and the same thing here, minus 6ix. Negative 3i times negative 3i is positive 9i squared. Alright, so it looks like we have an I squared term here. We know that I is equal to I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth, or I to the 0, is equivalent to 1. Now this is an I squared term, so we can replace it with negative 1. So let's put that in. Let's put negative 1 here and a negative 1 here instead of the I squared. X squared plus 6ix, sorry, minus 9 minus 4x squared minus 12ix minus 9. So the thing here is we can distribute this negative sign in so that we can just add the terms. So that gives us x squared plus 6ix minus 9 minus 4x squared plus 12ix plus 9. We know that these 9's cancel out, and we can do x squared minus 4x squared is negative 3x squared, and positive 6ix plus 12ix is 18ix. So it looks like this is equivalent to answer choice 3.
All right, question 11. Which expression is not a solution to the equation 2 to the t equals square root of 10? So let's quickly solve that first. Let's solve for t. 2 to the t equals square root of 10 using log base 2 for both sides and using our log rules. We'll get this here, this expression. Okay. This on the left simplifies to t. That's how you do logs. Log base 2 of 2 to the t is just equal to t, is equal to the log base 2 of square root of 10. Okay, so we know what t is equal to. It's asking us what it's not equal to. So let's do a couple things here. Log base 2 of square root of 10 is choice 2. That's the same thing. Using log rules one more time, this is actually also equal to log base 2 of 10 to the 1/2 power. That's a square root, right? And by the rule of logs, you can bring that exponent down as a coefficient in front. That's 1/2 log base 2 of 10. And that is choice 1. So we can eliminate that as well. All right, now we can try to, if we look at the next two here, we actually have different log bases. Here's a log base 4, log base 10. So there's a little log base changing rule that we have to know, and this is how the rule goes. Log b of a equals log base x, so that's the new base we're changing to, of a over log base x of b. So why don't we change it? Let's try to change it to a base 4, right? So we're going to have x equals 4. This is our new base. All right. So we have initially, this is our answer over here. We'll use this one. Log base 2 of the square root of 10 equals log base 4 of a, which is square root of 10 in our case, divided by log base 4 of 2. All right, so far it doesn't really look like any of these answers, but let's see if we can simplify. So the denominator here, log base 4 of 2, will actually be 1/2. If you put that on your calculator, it will get to 1/2. So this denominator here is 1/2. And again, if we, dividing by 1/2 is the same as multiplying by 2. So that's 2 times the log base 4 of rad 10, square root of 10. And just as before, as we did over here, we can, by that same reasoning, by using the log rules, right? Log rules, this 2 can come back up here as an exponent. So we'll have log base 4 of the square root of 10 squared, which is simply log base 4 of 10, because the square cancels the square root. That is answer choice 3, so that is still a solution to the equation, and by process of elimination, we have answer choice 4. All right, question 12. Consider the system shown below. We have 2x minus y equals 4, and quantity x plus 3 squared plus y squared equals 8. And it asks the two solutions of the system can be described as. So there's two primary ways to do this. We can simply graph it, and you can see where the intersections might be for these two graphs. Or we could try to do as we would normally do when we're trying to solve a system of equations. We set them equal to each other and see what x values satisfy the system of equations. So let's just rewrite this into y equals mx plus b type of form. So we have y equals 2x minus 4, just shifting some things around. And in this one we have y squared equals, and I'm going to move all this over, 8 minus quantity x plus 3 squared. Awesome. And then we can, of course, we can square root that as well. So that will give us y equals the square root of the entire quantity, 8 minus x plus 3 squared. Now, let's just set the two equal to each other. So 2x minus 4 equals the square root of 8 minus x plus 3 squared. I just want to get rid of the square root right now, so we can go ahead and square both sides. We could just do this, square the whole thing. So we'd have 2x minus 4 squared equals 8 minus x plus 3 squared. All right, let's just distribute out and kind of see all the terms, all the polynomial terms. So we can use FOIL here, which would get us 4x squared minus 16x plus 16. And that equals 8 minus x squared minus 6x minus 1. Okay, let's combine the like terms together. We will get 5x squared minus 10x plus 17 equals 0. So to solve this, to solve where these x's might be, I might just use the quadratic formula just to see what we get. So that again, let me write over here the quadratic formula. Okay, that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And just to be clear, this here is a, this is b, this is c. So why don't we plug in, let's just see what we get. Negative b would be positive 10, because it's negative, positive 10, plus or minus the square root of b squared, that is 10, negative 10 squared, minus 4, a is 5, c is 17, okay, all over 2 times 5. All right, so this is going to be 10, this is still 10. We really got to pay attention to what is in here to figure out if we're going to have imaginary, irrational, or rational solutions, right? So this is going to be 100. This is 10 squared. That's 100. But this here would be, we're subtracting 20 times 17. 20 times 17 is 340. Okay, that's going to be a negative number inside. And you cannot do a square root, or you won't have a real solution if you have a square root of a negative number. And so we know that both answers will be imaginary because everything inside the square root is going to be a negative. And taking a square root of a negative number will always get you imaginary roots. So the answer here is choice 1. All right, question 13. What is the solution to 8 times 2 to the x plus 3 power equals 48? So again, we might be invoking some sort of log rules here. Let's see what we can do first. So it looks like we could just divide both sides by 8. That's probably the simplest first step to do here. So just rewrite here. Divide both sides by 8. And we get right now 2 to the x plus 3 power equals 6. Now, just as before, we can take the log base 2 of both sides. I'll write it this way. So we'll have log base 2 of 2 to the x plus 3. That equals log base 2 of 6. And again here, log base 2 of 2 to the something power will just get you that power. So we're left here with x plus 3 equals log base 2 of 6. Okay, and we can subtract 3 from both sides. X equals log base 2 of 6 minus 3. Now, this matches none of our answer choices, so it makes us think perhaps we have to do some sort of log base changes to this term here. That'll start making us look like a couple of the answers, like choice 1 and choice 1, 3, or 4 here, right? So once again, just to review what the log base change rule is, we have log with the base of b of a equals log new base x of b over of a, log base x of a over log base x of b. So given that, let's change to an ln, natural log, so that's base e, right? So we can say that log base 2 of 6 equals the ln, that's again, let's just write here, ln is the same as log base e, or the natural number, ln of a, which is 6, over ln of b, which is 2, okay? And that starts to point to choice 1, because if we just write that answer fully out here, we just replace the log base 2 of 6 with this quotient of natural logs, we will get that x equals the ln of 6 over the ln of 2 minus 3. And that should be our final answer, choice 1. All right, question 14. The expression m squared over m to the 1/3, that whole quantity to the negative 1/2 power, is equivalent to which one of these? So the easiest way to do this is to make sure we know and are pretty fluent with our exponential rules here, okay, rules of exponents. So the first step we can do after we rewrite here m squared over m to the 1/3 to the negative 1/2. When you have these powers raised to another power, you simply multiply them. All right, that'll get multiplied into here. This will get multiplied into here. So we could get rid of that pretty quickly. This will be m to the negative 1 over m to the negative 1/6. Okay. Now when you have a quotient, of these powers, you can subtract the powers. So this would be equal to m to the negative 1 minus negative 1/6. We're going to subtract the exponents. Now that will turn into a plus sign because there's two negatives together. So we'll have m to the negative 1 plus 1/6. Okay, and we can rewrite negative 1 into negative 6 over 6. That's pretty easy, just so we can combine the fractions. And we'll get m to the negative 5/6. All right, so we're pretty close. It's actually, one of the answers is actually here already. Let's figure out what m to the negative 5/6 really means. When you have a negative sign, you can simply change this to 1 over the same term but to the positive power, right? It's just saying it's on the bottom, it's on the denominator. So we have 1 over m to the 5/6. All right. Now, when you take a power like this, like m to the 5th, that's pretty straightforward. When you have something like a fraction here, this over 6, you're saying that we're doing a 6th root. So what I'm trying to say here is, if, for example, this is just an example, if we had m to the 1/2, we'd be actually doing a square root. Okay, m to the 1/3 would be a 3rd root, so we have a little 3 over here. So in the same way, this over here now, going back to the problem, is actually 1 over the 6th root of m to the 5th. And that leads us directly to answer choice 2. All right, question 15. One of the medical uses of I-131 is to enhance X-ray images. The half-life is approximately 8.02 days. A patient is injected with 20 milligrams of I-131. Determine to the nearest day the amount of time needed before the amount of I-131 in the patient's body is approximately 7 milligrams. So what's important to note here is the half-life is 8.02 days. Okay? If you're not familiar with half-lives, they're actually relatively easy to understand. Let's use this as an example. 20 at the beginning. 20 on the first day you got injected, 20 milligrams. In 8.02 days, it halves. That amount halves, so that's 10 milligrams now. Okay, that's why it's called the half-life, because the half-life is 8.02 days. It halves to 10 milligrams. Likewise, you wait another 8.02 days, and you'll have that remaining 10 milligrams into 5 milligrams, and so on and so forth. The question's asking us 7 milligrams. Which day would that be, right? So if you wait 16 days, it's a little too long. You'd be at 5 milligrams. So we're looking for somewhere around here, and it's going to be under 16 days, and we can check that later with our answer. Approximately under 16 days. So it'd be good to model this with some sort of exponential decay. It's halving each time, so that's kind of our common rate. It's going to be half to the something power, right? So let's do this. Let's let t equal the time since injection. Okay. Specifically, days since the injection. Days. We'll say c of t, c being the concentration remaining, or the milligrams remaining rather, in that person's body, in that patient's body, is equal to the initial amount, and we'll say 0.5, because that's the rate, to the t power, right? So it's like having to the t power, depending how many lives it's been. However, we can't just leave it to the t, we have to make one slight modification. We said it takes 8.02 days for it to halve, okay? So by dividing that t factor on top by 8.02, okay, we can ensure that at 8.02 days, we'll have 0.5 to the 1 power, right? And that will have our initial amount, p. So that's a little trick you have to remember. You have to kind of divide it by the half-life, okay? So we can simply work this out. So we have c of t equals, we're looking for 20 milligrams initially, 0.5 t over 8.02. We're looking for 7 milligrams, so we can set this to 7, and then simply solve for t, okay? So we'll have, I'm just going to divide by 20 on both sides. It's 0.5 to the t, oh, I'm sorry, poorly written, 0.5 t over 8.02, okay? And we use our log rules here to eliminate the exponent here. So we can say log, using a 0.5 base of 7 over 20 equals, and if you do a 0.5 base here, you're just left with what's up here. So I'm going to simplify that just to here. I'm going to skip that one little step. Okay. And then we'll multiply by 8.02, both sides, 8.02 times log 0.5, 7 over 20 equals t. Okay, and when you put this into your calculator, you will get t equals 12.14 days, and they said to round to the nearest day. That'll give us 12 days. That's our final answer. All right, question 16. Julie averaged 85 on the first 3 tests of the semester in her math class. If she scores 93 on each of the remaining tests, her average will be a 90. Which equation could be used to determine how many tests T are left in the semester? All right. So let's do one really quick thing here first. She's averaged 85 on her first 3 tests, right? So that means test 1 plus test 2 plus test 3 all over 3, because there's 3 tests, taking the average, is an 85. So if we multiply the 3 over to the 85, we'll get 255. So we can say the sum of all the scores from her first 3 tests is 255. We don't actually have to know the individual scores. This is good to know, the 255. And it's good to see so far they're in all the answer choices. Here's the 255 in all the answer choices. Okay. If she scores a 93 on each of the remaining tests, her average will be a 90. So how can we represent that? We need to take these into account and the next couple tests, right? And that's 93 she needs to score, and she has T more of those tests, times T. So this is where I'm getting at. When we add the two, we get the total score, total of all the scores she had in her semester, right? So we will get 255 plus if she gets a 93 on the remaining T tests. Okay, so that'll, let's say it's 4 tests, right? So it's 93 times 4. It's just a total. This up here is just a total of all her scores. Now, we have to divide it by we're going to do an average, so we have to divide it by how many tests she's taken. Well, we know the first 3 tests, that's 3. Okay, so that's 3. Plus the remaining T tests that we don't know how many. We don't know how many those T are. So we'll put a T here, 3 plus T on the bottom. And they said that should average out to 90. So just by kind of dissecting that problem and translating the words into this number, this model here, we can just compare it to the answer choices, and it looks like choice number 3. All right, which statement regarding polynomials and their zeros is true? So we can just go through each one of them. I think it'd probably be the easiest way. So we're kind of going to be using what's called a factor theorem here. Okay, factor theorem. And the idea is just if you have a 0 of 1, okay, so if you have a 0, meaning it's a solution, right? 0 equals 1, then one of the factors has to be x minus 1. That's when you do the long division of that polynomial, you'll get no remainder, basically. Okay. Another way to think of it is if you graph it, it should pass the x-axis at 1. Okay. So let's see. This says it has zeros of 1 and negative a only. Here's a little problem. When we factor out choice 1, right, we have x squared minus 1, x plus a. This here is a difference of 2 squares. So we actually have x plus 1, x minus 1, and x plus a. So the zeros should be, you just set each one to equal 0 here. So for x plus 1 equals 0, x equals negative 1. For the second one, x equals 1. And for the last one, x equals negative a. So it's not right because it says only. This should say positive or negative, so that is out. Okay. Now, in the same way, if we do choice number 2, okay, we have x cubed minus ax squared plus 16x minus 16a. So we can actually factor this. It'll work out quite nicely, this cubic. We can group this and group this, and I'll rewrite this in green now. So we can factor the first part here as x squared times x minus a. We'll factor the second part now written in blue as 16x minus a, right? So now we have this shared factor among both of them. We'll rewrite this together as x squared plus 16 times x minus a, right? Because that's just, if you distribute that into here and here, we'll get the same answer as above. So if we have it written this way now, over here, it says that the zeros are 4 and 8 only. Well, if we plug in 4 into here, okay, if we plug in 4 into here, that will not get us 0 as an answer. Okay, so that is not actually one of the zeros, and that immediately eliminates choice 2. If we go to choice 3, similar reasoning, x squared plus 25, x plus a, okay? It says it has, or it's claiming to have plus or minus 5 and negative a. I can believe negative a, okay? But if we come in here and plug in negative 5 or positive 5, we won't get a 0. So that is actually not a 0 also, and that eliminates that option. So that leaves us, by process of elimination, with choice 4, and we can quickly show why that's true, because if we take choice 4, and we have x cubed minus 8x squared minus 9x plus 9a, we can once again group them into here as one, here as a second one, okay, and then rewrite as x squared, okay, x squared x minus a, okay. minus, we'll say 9 here, x minus a. And those signs should still work out. And if you look here now, we can pull out that x minus a. We'll be left with x squared minus 9. So the factors for this are plus and minus 3, right? The zeros, x equals plus or minus 3. And for this one, we'll have x equals a. And that matches the answer choices that they gave in choice 4. Right, this next question, we're going to consider the system of equations below. Okay, so here's equation 1, 2, and 3. And note we have 3 variables we don't know, so unknowns here. Unknown, x, y, z. Okay, and the idea here it's asking is what number is not the value of any variable in the solution of the system. So the first step here is to try to figure out how we might rearrange or manipulate these 3 equations to start solving for all 3 x, y, and z. So we can use a process like an elimination process using 1 and 2, equations 1 and 2. So we have x plus y minus z equals 6. 2x minus 3y plus 2z equals negative 19. Now, what's very convenient here is if I multiply the first equation by negative 2, okay? If I multiply that by negative 2, I'm going to get negative 2x, okay? Negative 2x minus 2y plus 2z equals negative 12. If I now combine it with this equation, okay, this was equation 2, that's plus 2x minus 3y and plus 2z equals negative 19. If I just combine those, I'll eliminate the x's. I will have negative 5y plus 4z equals negative 31. Okay, so you might think that got us nowhere, we still haven't solved for any variable. But it actually is quite useful because we've actually eliminated one of the variables already. All right, so now the next step would be to do equations 2 and 3 and eliminate one more variable, specifically variable x, okay? So we can just be left with y and z very easily, okay? So again, we're going to take equation 2, which is this here, plus 2z equals negative 19. Okay, we're going to take equation 3, and I'm not going to show this step, but I'm multiplying equation 3 by 2. So I'll just say here, equation 3 times 2, right? Because that will give us negative 2x, once again eliminating the x, okay? Minus 8y, this is equation 3, and that's a negative sign, so it's still minus 2z. This should be actually a plus sign. I'm only multiplying by 2, not negative 2. So negative 2x plus 8y minus 2z equals 17 times 2 is 34. And when we add those together, the x's disappear again. We have 5y here, okay, 5y. This is very nice. It actually eliminates the z's also. So now we have 0z, effectively 0, equals 34 minus 19. 34 minus 19, which is 15. Okay, well that's very easy. Now we actually have y here. We can very quickly solve for y, and y equals 3. So that is not going to be one of the answers. I can eliminate that. Very nicely, this will feed right into here. I'm going to start writing in green. So negative 5 times 3 plus 4z equals negative 31. This is negative 15, so if I subtract negative 15 or add 15 to each side, I'll get negative 31 plus 15. Negative 31 plus 15, which is negative 16. 4z equals negative 16. Again, easily solve for that, and we get z equals negative 4. Okay, so start boxing these answers. So it cannot be choice 4. Now, lastly, to solve for x, We now have y, we now have z. Why don't we just plug everything back in? Plug in to equation 1. That's x plus y minus z equals 6. We don't know x, so we'll leave that. We know y is 3, that was solved over here. We know z is negative 4, that's over here. And that should equal 6, okay? It should equal 6. So x plus 7 equals 6. Solve for x, and that equals negative 1. So that eliminates choice 1. Therefore, we can be confident that our answer here is choice 2. That is not a value of any variable in the solution to the system. All right, question 19. Determine for which polynomials x plus 2 is a factor and explain your answer. We're going to do this 2 ways. Okay, one is just by plugging in, one will be long division, just to show what that is. So option 1. So option 1, we're using again the factor theorem, which again generally boils down to if x plus 2 or x plus a, whatever it is a factor, then here we have negative 2 is a 0, which means when you plug in negative 2 into the function, it should get you back 0. And that again is because x plus 2 is a factor, okay, via the factor theorem. So let's try it out. Let's go p of negative 2. Let's just plug that in. Let's see what we get. So we get negative 2 to the 4th minus 3 times negative 2 to the 3rd minus 16 times negative 2 minus 12. Let's work this out. Negative 2 to the 4th is 16 minus 3 times negative 8 is negative 24. That's actually plus 24. Okay. This is plus 32 minus 12. And that will not get us 0. Okay, so that is not equal to 0. So that is not, this will not be one of the answers. Okay, it's not a factor. X plus 2 is not a factor. Let's try q of negative 2. So it's negative 2 to the 3rd minus 3 times negative 2 squared minus 16 times negative 2 minus 12. If we work this out, this is negative 8. This is negative 12. Add 32 minus 12. Okay. So this here is negative 20 plus 32 minus 12. This here is 12 minus 12 equals 0. So that works out. So we know Q is the answer, and just by showing this, you can justify that. Option 2 is to use long division. Okay, this is long division. All right, so I will only show it for the correct answer because it's going to take a couple steps here. So if it is a factor, if x plus 2 is a factor, we should divide q of x by x plus 2, and our remainder should be 0. Okay, so we'll set up this long division here. Set up this long division. X cubed minus 3x squared minus 16x minus 12 divided by x plus 2. All right. So the first thing we do is try to match this x cubed here and this x. So we need an x squared to do that. Okay. And if we do an x squared, we'll be left with an x cubed here minus, or sorry, plus 2x squared, right? So just like we do in division, we now subtract and see what our remainder is. So this cancels to 0, but this gives us negative x squared. We can bring down the remaining factors as well. It's minus 16x minus 12. Awesome. So now, how can we get from x to x squared? Okay, so that will be, or to negative x squared here. So we want to go to, we need an x here to get to x squared. The sign just noticed an error, so we were subtracting here, so this actually has to be a negative 5 because we're really adding negative 3 and negative 2. There should be a subtraction here. Okay, so Up here now, we need to have a 5x so that we get a 5x squared here. 5x squared. And we're going to be subtracting. Okay, so we get a negative here. And we can just follow through with our math. Negative 5x times positive 2 over here is a negative 10x. Okay, we want to subtract all of that. This leads us to 0 here. There we go. These cancel. This will leave us with a negative 6x minus 12. Okay, and that's pretty straightforward now. We can simply say times negative 6 up here. That'll give us negative 6x minus 12. And again, subtract that. We'll just cancel both to 0. And our remainder is 0. Right? So in essence, we're saying this q of x here can be factored into x plus 2. And then another polynomial here, x squared minus 5x minus 6, with a remainder, again, of 0. I won't show p of x, but when you do this division for p of x, you will find that your remainder is not 0, and that's why it is not a factor. All right, question 20. This is the last one of our algebra type questions in our Algebra 2 review. Justify why this fraction is equal to x to the negative 1/12 times y to the 2/3 using properties of rational exponents. They just add here that x and y won't be equal to 0, because if they were, we'd have zeros in the denominators here, and that would be an indeterminate form. So let's remind ourselves this one fact. Okay, if we say m to the 1/2, that's the same thing as saying the square root of m. M to the 1/3 is the same thing as the cube root of m. Okay, so let's just remember those rules, that if it's something to some fraction power, like 1/2 or 1/3, it's the same thing as doing some sort of root, okay, of the expression within the root term. So why don't we break it apart? Let's do the numerator first, the numerator. Okay, so cube root just means it's all that to the 1/3. So that's x squared y to the 5th all to the 1/3. When you have exponents like this, okay, you just multiply it in. It's like the distributive property. Okay, so that's x to the 2/3 y to the 5/3. Let's do the denominator in the same way, denominator. So we have x to the 3rd y to the 4th to the 1/4 power. Okay, that will give us x to the 3/4, multiplying that in, times y to the 1 power, right? 4/4 is 1. Okay, so effectively we have this as our answer. But now we have to simplify it a little more to get to this form. So let's do the x's first. We're doing a quotient. We're doing x to the 2/3 over x to the 3/4, right? And by the properties of rational exponents, this is the same as subtracting the exponents, numerator minus denominator. So x to the 2/3 minus 3/4. We need to put that in some form that we can actually simplify and subtract. Okay, so 2/3 is the same as 8/12. 3/4 is the same as 9/12. Okay, so 8 minus 9 is negative 1. Negative 1/12. So that's looking pretty good for here. Let's do the y. Y to the 5/3 over y to the 1st. Okay, y to the 1st can be rewritten as 3/3 pretty conveniently. So we can just say, subtract again, y to the 5/3 minus 3/3. That gives us y to the 2/3. Okay, this is all in the numerator. So now when we combine the two one more time, we simply have x to the 1/12, y to the 2/3. That matches our problem statement here.
Alrighty, now we're moving on to the topic of functions, which will cover the next 14 questions. That's question 21 to question 34, including 34. Alright, so describe the transformation applied to the graph p of x equals 2 to the x that forms a new function q of x equals 2 to the x minus 3 plus 4. Yeah, we can simply write this out as we can see what changes are made between this p of x to q of x. We see that x has now become x minus 3, so let's just write q of x in terms of p of x. It looks like it would just be p of x minus 3 plus 4, right? Now when we add a constant to a function, all that means is you're shifting it up by that amount. So this is shifted up by 4. Now you also have this x minus 3 term. Now it's always the rule that x minus 3 shifts it right rather than left. So a negative means it shifts right. Shift right by 3 units. So this is it. This is just a translation where you shift up by 4 and shift right by 3. Now, if you need further convincing, you can simply graph this in your calculator, graph that 2 to the x, and also graph that 2 to the x minus 3 plus 4, and you'll see that it is indeed shifted up by 4 and to the right by 3. Alrighty, so in this question we have a 7-year lease for office space, states that the annual rent is $85,000 for the first year, and will increase by 6% each additional year of the lease. So what will the total rent expense be for the entire 7-year lease? So it's asking us for the total rent. So that's adding up every single year. All right, so for the first year, we know that we're going to have this 85,000, right? For the second year, we're going to have 85,000 times 1.06. Now this is equivalent to multiplying 85,000 by, I'll just write it down here. It's equivalent to 85,000 times that increase 0.06 plus the original amount, right? And this to the first power. And then we can continue that pattern where we have 85,000, and in the second year it would be 1.06 squared. And this is the third year. And it just continues. This is for the fourth year. And the fifth year would be fifth year, sixth year, and then by the seventh year we have 85,000 times 1.06 to the sixth. So this would be first year, year 1, year 2, year 3, year 4, and 5, 6, 7. Right? So you can also see that this is a geometric series, right? Now we can either add it up this way and grab our answer from there, which would be, when we add it up, we get $713,476.20, which would be this. But a simpler way would be to initially identify that this is already a geometric series and use the geometric series formula. Now that formula is S of n equals a1, which is our first term value, times 1 minus the rate to the nth power over 1 minus r. In this case, r is not 0.06. Rather, because we're multiplying by 1.06 every year, r would actually be 1.06. And because we want the seventh year, n would be 7. And we also know our first term, a1, which is $85,000. So this formula would be 85,000, when you plug in all the values, 85,000, 1 minus 1.06 to the seventh, we're finding the seventh, the sum at the seventh term, 1 minus 1.06, right? So doing this, putting it into a calculator, you also get the same number, 713,476.20. So in this question, Evan graphed a cubic function, f of x equals ax cubed plus bx squared plus cx plus d, and determine the roots of f of x to be plus or minus 1 and 2. What is the value of b if a equals 1? Now let's identify what these roots mean. Let's go with the root positive 1, right? So that means having a root of positive 1 means that x minus 1 is a factor of f of x. Because when you plug in 1 in this term, it makes the entire function 0, right? So it's the same for the other two roots as well, meaning x plus 1 is a factor, and x minus 2 is also a factor. Now, if we multiply these out, let's start with the first two terms. We get x squared minus 1, and then we can multiply that by the x minus 2 term. We get x cubed minus 2x squared minus 1x plus 2. Now in this case, we can identify that this coefficient is a, this coefficient is b, this coefficient is c, and this coefficient is d, right? A does indeed equal 1, which makes b equal to negative 2. However, there's also another way to go about doing this. Because you know that each one of these roots make this function equal to 0, you know that f of 1 equals 0, so does f of negative 1 equals 0, and so does f of 2. That also equals 0, right? So doing this, you can just plug in these x values. I'll give an example for f of 1. You can just plug that into the function and get, with a equals 1, you get x cubed, which is 1 plus b x squared, which is just 1, plus c plus d. And you can do the same thing for the other two, plugging in the other two x values. And essentially what you have is a system of equations where you can quickly solve for b as well. So in this case, the answer is negative 2, and that's answer choice 4. This question asks, which equation represents the equation of a parabola with focus negative 3, 3 and directrix y equals 7? So let's quickly draw it out to visualize what we have here. So we have a focus at negative 3, 3. And then we have a directrix at 4, 5, 6, y equals 7. Now, given our focus and directrix, we know that our focus, over here, has to lie inside the arc of the parabola, and our parabola should be facing away from our directrix, with its vertex halfway in between our focus and directrix. So our parabola should look something like this. Now, we know that parabolas can come in two forms: a vertical type parabola where it points up or down, and a horizontal parabola where it points left and right. So the equation for a vertical parabola would be in the form of x minus h squared equals 4p times y minus k. With the horizontal parabola, we'd have y minus k squared equals 4p times x minus h. So here we have our vertical parabola equation, and that's what we have here. So let's use it. We know that h and k represent our vertex located right here. And we already have our h value, which is negative 3, because it lies on this line. Our k, we know, is, as I said before, it lies halfway between our directrix and our focus. So we have our directrix at 7, and we have our focus at y equals 3. We can simply take the average or the middle value of these two values, and we get 5. So our vertex is at negative 3, positive 5. So now let's try to find p. P is this distance. It's the distance from the directrix or the focus to our vertex. So in this case, 7 minus 5 would be 2. So our p has to equal 2. So now that we have p equals 2, let's be a little more thorough and find the actual value of p, because it could be negative. In this case, we know that the directrix y in this case, I'll put y subscript d, equals k minus p. That's our formula for the directrix. And in the same manner, the focus, the y value of the focus, y over focus, should be k plus p. So we know we have our k value over here, this 5. So we know that our directrix yd, which we know equals 7, it was given to us, equals 5 minus p. So that would mean solving this out, if you subtract 5 on both sides, you'd have 2 equals negative p, meaning p actually equals negative 2. And doing it here with the y value of the focus, we also arrive at this conclusion. So p actually is negative 2 rather than positive 2. However, you can do this later as when we're looking through the answer choices to see which direction this parabola faces, and put the negatives as you see fit. So let's take this vertical parabola equation, and let's fill it in with the values that we have. So we have x minus h, equals 4p times y minus k. So we know that our h and k values are negative 3 and 5 respectively. And then now we know our p value is negative 2. So this would be x plus 3 squared equals negative 8 times y minus 5. And now we can simplify this out and divide both sides by negative 8. And then that would be 1 over negative 8 times x plus 3 squared equals y minus 5. And now adding 5 on both sides, you get negative 1/8 times x plus 3 squared plus 5 equals y, which would be answer choice 3. So if you had p equals 2, you can see that when you're reading through the answer choices that it would look wrong, because having it positive would mean that the parabola would be pointing up. So once you see this error, you know that, oh wait, this parabola is actually pointed down, therefore the coefficient has to have a negative value on it. Alrighty, so given f of x equals 1/2 x plus 8, which equation represents the inverse g of x? Alright, so a quick shortcut to figuring out the inverse of a function is to simply switch the x and y values of it. So this one is y equals 1/2 x plus 8. Now if we switch the x and y values, x equals 1/2 y plus 8. And let's just put that in our y equals mx plus b form. So we can subtract 8 from both sides and get x minus 8 equals 1/2 y, and then multiply both sides by 2, and get 2x minus 16 equals y, giving us answer choice 2. And we can verify that simply that this is our inverse function by plugging in an x value up here, and then getting our y value, and then plugging that y value into our inverse function, and then our output should be our original x value, right? Alrighty, so in this question we're going to hand graph x cubed minus 6x squared plus 9x plus 6 on the domain -1 is less than or equal to x is less than or equal to 4. So the way I'd recommend going about doing this is to just graph this function out on your calculator and generating a table from that and applying the points corresponding to these x values. However, you can also do it manually by just plugging -1, 0, 1, 2, 3, and 4 into this original function, and then getting the y values from that. I can just quickly do f of -1 for you guys. F of -1 is -1 cubed, which is -1. Now -1 squared is +1, but so it's just -6, plus 9x, which is because x is -1, it's just in -9 plus 6. So these two values we know cancel out, and that would equal -10, and that would be our first point. I'm going to plot it here. I'm going to put -1 here. This is +1, this is +2, +3, and +4, just so we have enough space. So continuing on, let me just populate the rest. F of 0, f of 1, f of 2, f of 3, and f of 4. And this equals 6, this equals 10, 8, 6, and 10. So f of 0 is 6, 1, 2, 3, 4, 5, 6, right here. And 10, 10, and then 8, and then 6, and then 10 again. So we know that this is a cubic function, so it looks something similar to that, right? So let's just draw this out. And that should be our final answer. This question asks, which function is even? So remember, even functions are when f of -x is equal to f of x. And just as a side note over here, we also have odd functions, and remember those are f of -x equals negative f of x. So here we're only concerned with even functions, so let's see if each one of these answer choices is even. So answer choice 1, we have sine of x. Now is sine of x equal to sine of -x? Now I can think of one example where this isn't true. That's pi over 2, right? So sine of pi over 2 is 1, but sine of negative pi over 2 is -1. So this doesn't work. We can cross this out. Let's look at answer choice 2. X squared minus 4 equals -x squared minus 4. So this looks like it is true because squaring that negative sign helps us get rid of it. So this one would be true. So this is fine. Let's just double check the final two answer choices. This is the absolute value of x minus 2 plus 5. Now does that equal -x minus 2 plus 5? No, it doesn't, right? These values inside the absolute value do not end up being equal. Let's look at answer choice 4. You have x to the 4th plus 3x cubed plus 4. Does that equal -x to the 4th plus 3 times -x cubed plus 4? Well, no, it doesn't, right? Because while this answer takes out that pesky negative sign, this one doesn't. This one still maintains its negative sign, so this one doesn't either, meaning our answer is 2. All right, so the value of a new car depreciates over time. Greg purchased a new car in June 2011. The value v of his car after 2 years can be modeled by the equation log base 0.8 of v over 17,000 equals t. What is the average decreasing rate of change per year of the value of the car from June 2012 to June 2014 to the nearest $10 per year? Alrighty, so let's take a look at what t has to be to give us these values, right? The values at 2012 and the values at 2014. here it says after 2 years, so we know that from June 2011, June 2012 is just 1 year after. So June 2012, t equals 1. And in the same manner, when it's June 2014, you can see that t equals 2011, 2012, 2013, 2014, 3. Alrighty, so let's try to plug that into this equation, but let's for sanity's sake, I'm going to try to convert it to get rid of that log, right? So now it's base 8.8. So we can rewrite this out as 0.8 to the t equals v over 17,000. Now we can bring this 17,000 over to the other side and get 17,000 times 0.8 to the t equals v, which is something that that's more recognizable as a depreciation equation, right? So let's plug in 2014's value here, right? Then we can try to find that slope between those two, between the 2 years. So let's plug in 3. So 17,000 times 0.8 to the third equals, let me put that in my calculator. And the answer is 8704. And then we can do it for when t equals 1, which is June 2012. $17,000 times 0.8 to the first, which is just 0.8, which gives us 13,600. Now we can just find the slope between these two values. We know that because it's per year, and there's a time difference here of 2 years, right? We can just find the difference of this and then divide it by 2 years. So rise over run, right? So 13,600 minus 8,704, and we divide that by 2 years. And in this case, we get $2,448 per year. And then it asks us to round it to the nearest $10, so put simply, we can just round this up to 2,450. So which equation is represented by the graph shown below? By looking at the graph and by looking at the answer choices, we know that this is some sort of cosine graph. Let's draw the cosine graph over here on the right. And 2 pi. All right, so this is what our cosine graph looks like, right? Cosine of x. So I'm going to superimpose this new graph on top of it as well. It looks like this. So let's figure out how much this graph has been stretched or squeezed or stretched vertically and squeezed or stretched horizontally. Let's look at vertical first. It looks like this graph has been squeezed vertically from having the upper and lower bounds of -1 to positive and -0.5. So we know that it's halved, right? The amplitude has been halved. So we can write 1/2 cosine. So we know there has to be a 1/2 before it. Now that immediately eliminates answer choices 2 and 4. Now let's take a look at how much this has been changed horizontally. You can see that it also has been squeezed horizontally from here to here. Meaning we have to add because it's a squeeze, it's a 2x rather than a 1/2x. Remember that if you do 1/2x, it would widen the graph rather than squeeze it. Having it at 2 would squeeze the graph. Therefore, our answer is answer choice 1. This question asks us for the inverse of the function y equals log base 3 of x. So we can rewrite this out as 3 to the y equals x. Now, because we're trying to find the inverse, we can flip the x and y values as a little shortcut. It becomes 3 to the x equals y. And that would be answer choice 3.
So in this question, we want to use this identity, very popular trig identity, sine squared theta plus cosine squared theta equals 1, to find the value of tan theta to the nearest hundredth if cosine theta is negative 0.7 and theta is in quadrant 2. So we saw this already before. All students take calculus, and that's for quadrants 1, 2, 3, and 4, and that just represents where certain trig functions are positive again. So just to remind ourselves, in quadrant 1, A, that means all of them are positive. S is for sine, T for tangent, C for cosine. So we know this angle, it says theta is in quadrant 2, some angle like this, let's just call it theta here, okay? And we know if we're finding tangent, we want a negative number. To remind ourselves, sine theta over cosine theta is tan theta. So maybe that's something we can use to start solving. So here's option 1. Option 1 is to solve for sine theta and then put it in this form that we just mentioned here. So we can solve it this way. Sine squared theta using the identity plus cosine squared theta, so that's just negative 0.7, which they gave us, cosine, squared, right, equals 1. Sine squared theta, and I'm going to just move this over to this side, will equal 0.51. So sine theta is about, when we do the square root, about 0.7141428, ... a bunch of other decimals there. Now, we have that number, we have cosine. So if we put those together, we do the sine over cosine here, sine over cosine, we'll get about 0.7141428, ... all divided by the given 0.7. This gives us negative 1.02 for tangent, right? Because this does equal the tangent of theta. That's the correct answer. Now there is a second way to do it as well. Okay? So instead of solving explicitly for sine, etc., we can manipulate the initial equation first. So we have sine squared theta plus cosine squared theta, that equals 1. Why don't we take some time and divide everything by cosine squared theta, and cosine squared theta, okay? This cancels to 1, this cancels to tangent squared theta, right? Again, that's basically using this identity here, right, this relationship. So now we have tan squared theta, I'm going to move the 1 over to the other side, so we have 1 over cosine squared theta minus 1. Well, I might as well take the square root of both sides since we're finding tan theta. So we'll have tan theta equals the square root of 1 over, we know what cosine theta is, we can square it one more time, that's the negative 0.7 squared minus 1. And when we plug that into our calculator, this expression on the right, we get the same answer, tan theta equals negative 1.02. And just to check with our intuition from before, we said because this theta is in quadrant 2, we're taking the tangent of theta should be a negative number. And that checks out for both of our answers. All right, question 32. Which graph has the following characteristics? 3 real zeros, and as x approaches negative infinity, the function behaves such that it goes to negative infinity. And likewise, x goes to infinity, the function behaves such that it goes to infinity. So we just have to understand some vocabulary here, okay? Let's do these first, this is a little easier. So as we keep going this way, the function should keep decreasing, okay? Well, we see here this is going up as x decreases. That's not the answer. Choice 2, as we go this way, the function f of x still goes up. That's not the answer. These two are good, they go down, okay? So that satisfies this so far. So we're done looking at this rule. In the next one, as x approaches infinity, f of x approaches infinity. So as we go forward this way, it should increase, right? The function should increase. This is good. It goes up as x increases. So we'll keep that one. This one's not so great. As we increase, the function value goes down, decreases. So that's not the answer. So just by process of elimination, not even using this first rule, we are pretty sure its answer is 3. Just to double check, 3 real zeros, if we count here, 1, 2, 3, that also satisfies it. So answer 3 is the answer. All right, which value to the nearest tenth is the smallest solution to f of x equals g of x? And they give us both f of x as a function here and g of x. So let's quickly just translate what that means so we know what we're looking for, right? They're basically asking us, what should x be equal to, right? What is the solution? What is x? Such that f of x equals g of x. In other words, and this is how I started thinking of it, if you graph them, where would they intersect, right? At what x value would they intersect? So this graph was not provided, but I've inserted it here for our reference, okay? You can easily put these two functions into your calculator and find the intersection point. And we find that there's 3, 1, 2, and 3. But again, the problem is asking us what is the smallest one, right? So we're just finding which is the smallest x value, and that would be this one right here. I have the coordinates written out. So we have x equals 2.055, and they would intersect. They're asking us to round to the nearest tenth. So that's a pretty quick fix. That's just 2.1. We're pretty confident that will be choice 2, negative 2.1, choice 2. Okay, in this next problem, question 34, we are given a the degrees Fahrenheit in Times Square during a day in August by this function t of x equals 8 sine of 0.3x minus 3 plus 74, where x is the hours after midnight. And according to this model, the predicted temperature to the nearest degree at 7 p.m. is. Okay, so let's get the easy part out of the way. 7 p.m., okay, where x is the number of hours after midnight. So, you know, here's 12, here's 7. At midnight, if we go 7 hours, that's only 7 a.m. We have to go another 12 hours to get to 7 p.m., right? So that's 7 plus 12, sorry, that's a 1, 7 plus 12 equals 19 hours. So we know x is going to be 19. Now this is very simple. All you have to do now is just plug this into your calculator, this t of x here. The one thing to look out for though, so look out, is unless it's otherwise specified, you want to make sure you're doing your trig calculations in radians, okay? And there's a big difference, radians and degrees. So when we put this in our calculator, when we say 8 sine of 0.3 times 19 minus 3 plus 74, plus 74, there we go. This quantity in here has to be in radians. It's expressed in radians. So it finds the sine of that in radians. When we do this answer, okay, when we solve it properly with radians, we very quickly get answer choice number 3, which is 77 degrees. Now, here's the thing we have to look out for, right? If we did this in degrees instead of radians, right? If we did this in degrees, okay, it would have actually given us 74 as the closer answer. We would have ended up picking choice 2, which is incorrect. So we just have to make sure, again, when we're doing trig calculations, please, please, please make sure to put your calculator in radians. All right, well, that concluded our function section. We're now going into the last 6 questions, which are all for stats and probability. So our first question here is very easy. It's just a definition you have to know. Which situation best describes conditional probability? And without looking at the choices, we should know that conditional probability is what is the probability of something happening given that we got this knowledge that this other event had already occurred. Okay, that's almost verbatim choice 4. Okay, that's the definition of conditional probability. So that's something that's very good to commit to memory. The other 3 explain some other things in probability that some of them don't really even have a special name, Like probability of an event occurring once is just the probability of it occurring once, for instance. There's nothing much to that choice. So we'll just commit that one to memory. Choice 4, probability of an event occurring given another event has already occurred. All right, question 36. A sociologist reviews randomly selected surveillance videos from a public park over a period of several years and records the amount of time people spent on a smartphone. This statistical procedure is called, okay, again, this is a definition. We can think about a couple things and try to reason it out. So choice 1, a census, right? A census, typically, think about the United States Census, for instance, every 10 years or so. That tries to capture the entire population. They're trying to get whole population to respond, okay? So that's not what we have here, right? We're not trying to survey a bunch of people. This person simply has surveillance videos that are randomly selected. They've been recorded already. So we're not going to say it's a census. In option 2, an experiment. An experiment is something that usually you have some sort of control group, we'll call them C, and you have some sort of experimental group. And you impose some sort of change on the experimental group to see if they're different from the control group. We're not comparing two things here. There's no experiment to be done. We're not imposing anything on any of the groups, right? So it's not an experiment either. An observational study. Well, this one I like a lot because we're taking observations from these surveillance videos, right, and recording some data from it, right? We're observing that information. So I like choice 3, but let's just look at choice 4 for a second, a sample survey, okay? A sample survey is usually a pretty active sort of sampling method where you actually go out and talk to people and survey them. You sample, maybe every 5th person that comes out of the store or something. That is not the case here. We are randomly selecting videos that have already been recorded. So this is better explained by an observational study. All right, question 37. A survey about television viewing preferences was given to randomly selected freshmen and seniors at Fairport High School. The results are shown below in the table. Okay. A student response is selected at random from the results. State the exact probability that the student response is from a freshman, given that the student prefers to watch reality shows on television. This is a conditional probability. We kind of defined that before in one of the first questions we talked about for stats and prob. So conditional is what is a probability of this given something, right? Given we already know some information. And here we are already given the information that this student that we're choosing prefers to watch reality shows. So we're only looking at this column, right? So this is kind of how we're going to set it up. Okay. The conditional probability will be response is from freshman. Okay, so freshman divided by, so that's given, you would do a division, given the student prefers to watch reality shows. So given reality. Okay. Well, this is pretty simple. Okay. We want a student response that's a freshman given reality. So reality is 110 seniors plus 103. And for the response to be a freshman, that's 103 of them, right? 103 within reality show. So we don't have to make this a decimal. We can leave the exact probability as this, 103 over the sum of these here, 213. All right. The probability that Gary and Jane have a child with blue eyes is 0.25. So let's just start writing stuff on the side here. 0.25. Blonde hair is 0.5. And child with both blue eyes and blonde hair, okay, is 0.125. Given this information, the events blue eyes and blonde hair are dependent, independent, or mutually exclusive. So we have to start defining these terms first to better understand them. Okay, dependent means if one happens, it will affect the other one. okay? On the contrary, we have independent, where if you had blue eyes, for instance, it has nothing to do with whether you're going to have blue hair. Mutually exclusive means if one happens, the other one can't happen, okay? So let's talk about 3 first, okay? I would argue that if you had blue eyes, you can't also have black eyes, right? They're going to be blue. We're assuming here we can't have like a dual color, one eye is one color, one eye is another color. We'll assume that they're all the same. So these are completely unrelated in the sense that blonde hair would preclude you from having black hair also or brown hair also. It's not about eyes, right? So I would not say these two are mutually exclusive. So I would immediately eliminate choices 1 and 4. Okay, so now to test for independence, right? So it won't be, we know it's either going to be dependent or independent, right? So we have this rule, the probability of A and B happening, okay, if independent, should result in simply the probability of A times the probability of B. Basically, they have nothing to do with each other, and you can simply multiply the two probabilities. So this, if true, we're saying that these two events having these two events, blue eyes and blonde hair, are independent. So we quickly do that test, okay? So probability of A times the probability of B is 0.25 times 0.5, and that gets us 0.125, okay? And we're given, right, that the probability with a child of both blue eyes and blonde hair, so that's this here, P, A, and B, is also 0.125. So this number and this number check out, and like we said before, if this is true, they are independent. Okay, blue eyes and blonde hair are independent. So that gives us choice 2. Okay, in this next question, a suburban high school has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. If the probability that student participates in either sports or music is 974, what is the probability that a student participates in both sports and music? All right, so this one we have to break down a little bit. I like to see it in a Venn diagram. So the entire school can be represented by this box, okay? And we're talking about a population of 1,376 students. Within it, there's 2 categories, right? 1, 2. In fact, let me do this one in a second color so we can kind of see everything a little better. We'll do it in green. Okay? This first one here will be the people in sports. Red is sports, okay? And that has 649 people, that entire red circle, okay? That's including the overlap. So the whole red circle is 649. For the green circle, we have people doing music, and that's 433. So there's some overlap in the middle. I'll color it in blue, okay? And we can quickly find what that overlap is, right? Because this is the whole population. This is the whole school population. So if we add these two numbers, 649, okay, 649 plus 433, okay, we will very quickly determine that the sum of that is 1,082. 1,082. Okay. So that's fine. We're not over the 1376. That's fine. But we just added 2 numbers, so 2 of these circles, right? But we've double counted what's in here, in that overlapping region. Okay? Now, let's keep that in mind because we're going to talk about this number next. They say that the probability that a student participates in either sports or music, that's represented by this here. I'm coloring it in this deep purple, this indigo color, okay? So not overlapping, it's either sports or music. So it's just this part, okay, and this part. and counting this overlap just once. Just once. So here we've double counted it because we've counted two circles separately and added them, right? So we can quickly find just what that difference is, okay? 1082 minus this numerator here, 974, okay? And that gives us 108 of overlap. 108 of overlap. So that tells me that that middle region, there's 108 students that are in both sports and music, right? So to do the probability now, we can do the probability. That's 108 students over the entire school, which is 1,376. That's our final answer. And our last question here. A candidate for a political office commissioned a poll. His staff received responses from 900 likely voters, and 55% of them said they would vote for the candidate. They conducted then a simulation of 1,000 more polls of 900 voters, assuming 55% of voters would vote for their candidate, and their output is shown here below. Given this output, and assuming a 95% confidence level, the margin of error for the poll is closest to. All right, so this one is a formula that you should probably memorize. It's not on the formula sheet, I believe. The margin of error, okay, in something like this is the z-score times the square root of p1 minus p over n. And let's talk about each variable here real quick. I'm going to label these in blue. The z-score depends on confidence level, okay? Depends on confidence. In our case, it's a 95% confidence interval, and the z-score, the corresponding z-score for that will equal 1.96. That's just something that you probably should memorize or get a feel for, that 95% confidence level. Over here, the n represents the number of trials we had, number of simulations, right? So number of simulations, and we have 1,000. P is the proportion that votes for our candidate. This will be 55%. Okay, that's P. So 1 minus P would be 45%. So let's quickly just do that math. The margin of error is equal to 1.96 times the square root of 55% expressed as a decimal here, 0.55, times 1 minus 0.55, all over 1,000. And when we solve that out and put that in our calculator, we'll very quickly get 0.0308. And that is pretty close to answer choice 2. So this concludes our Algebra 2 review. We would like to thank you guys for listening, and we wish you the best of luck on your exam.